All right, hey everyone, let's do it. So, problem one, there is an idea of limit, and the limit is asking, like, what's your best prediction, or what does it look like it should be? So, limit x goes to something, we'll say -1 to make it match my problem, and that'll be of f of x is equal to, something. Okay, so this is asking you a question. That's why it ends in a question mark. And it's saying, as x approaches -1, what does it look like f of x approaches? So, sorry, this arrow here, every time you see it, you can replace it with the word approaches, which, 2p's, 1p, who cares? You get it. All right. So as x gets closer and closer to -1, what does f of x get closer and closer to? So looks like x equals -1 is the first dashed line. You know what? Let's just go ahead and copy this image. Sorry. And copy image and paste it over here. All right, sweet. So x equals -1 is this line, and if I'm walking along the curve and I'm getting my x position closer and closer to -1, doesn't matter if I'm coming from that direction or that direction, I'm approaching this y value right here, which, let's see, so this is -2, 4, 6, this is about -5, so -5 is the answer here. This is what I want, nope, let's put this around, -5. Okay, cool, whatever, and this is a case where f of -1 happens to also equal -5, but that's not the case in part B. So again, what does it look like f of x approaches as x approaches 0? So first off, notice f of 0, it doesn't exist, okay? But if I'm approaching 0, if I'm a bug crawling along this curve or coming along this way, as I approach 0, I'm approaching this value right here. I'm going to fall in that hole, right? So here you get -6. It looks like f of x approaches -6 as x approaches 0. So, all right, pop this back around, -6. Okay, so now as we approach +1, it depends on the path we take, right? If I'm a bug crawling along here, it looks like I'm approaching this y value, whatever that is, 4, 6, 8, 9, okay? But if I'm a bug crawling along here, it looks like I'm approaching that y value, which is -5. So the fact that it depends on the direction you take, now we say the limit does not exist, okay? The mean girl scenario. All right, D and E. Okay, how about as we approach +4? So as we approach +4, we have another time where f of 4 is not the answer. F of 4 is this spot right here. But as I approach x equals 4, what f of x is getting closer to, what my y value gets closer to, is this spot. That's the y value I get closer to. Okay, so what was that spot? 18, 16, I think 15. All right. Cool. Let's take a peek. Great. So that's what a limit is. It's what it's the y value you get closer to, not necessarily the y value that the function is. Okay, or it's like your best guess. What does it look like the function approaches? Okay, so how can we figure out limits? Let's pop open Desmos really quick. All right, and I had sine of 4 theta, but I'm going to do 4x divided by x. And notice what happens as x gets closer and closer to 0, right? This function gets closer and closer to 4. And okay, sweet, cool. And you might say, well, so they just wanted my function at 0? And I would say, no, they don't, because your function at 0 is undefined. It doesn't exist. You're going to have a 0 over 0 error, right? But it should be defined, right? And that's why we have a limit, okay? It's because, God damn it, it should be 4. No matter how much I zoom in, that's actually kind of a lie. Here, I'll show you. Eventually, Desmos breaks down. I don't know what zoom level it takes, so I'm going to keep rambling for a bit, and if we don't break... Oh, it just stopped. All right, well, I can do it on my computer, so I'll do it in class sometime. But you will see Desmos breakdown, and f of 0 is undefined. But it really should be 4. Okay, that's something called a removable singularity. So just graph your function and see what it should be at 0. Okay, cool. Next problem. All right, exact same idea. Just graph this function, and this time we're going to approach -7. Okay, so this was, oh, I actually could have left that. It doesn't matter. X squared minus 49 divided by x plus 7. All right. So, is that what you thought it would look like? Guess not. You know, most people are pretty surprised by it. Oh, we already have f of x. What is f at -7? Oh, it's undefined. That's right. But wait a second. This looks like it's just a line, right? You could figure out what line this is, and it's actually x plus 7. No, x minus 7. Sorry. There you go. See, I just covered it up. Boop, it's back. And so as you approach -7 on your line, which is x minus 7, -7 minus 7, you'll get to -14. And in fact, right, if I were to graph x equals -7, then you can see that we intersect right here at 14, or -14. Okay, so -14. Sweet. All right, so the word derivative we can replace with slope. And this is already filled in because we did it in class today. I'll still quickly go over it. So I gotta copy this. Copy image. All right, paste, sweet. So the word derivative we can replace with slope. Okay, derivative. You can always replace that word with slope. So for part A, it says the derivative, wait a second, the slope, there we go, the slope of the function is positive when? Just pick any point where it's positive. It's positive here, 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 right? So I just went with x equals 1, but there's infinitely many x choices that you could do, okay? All right, the value of the function is positive when? Oh, okay. So now we actually just want the value, and it's positive in this region, it's positive in this region, okay? So any x value in there, so I went with 1.5. Which happens to be this dashed line here. Okay, so that's part B. Part C, the slope, right? Whenever you see derivative, replace with slope. The slope of the function is largest when? Okay, so largest slope means most positive, and I was thinking it sort of looks the steepest over here. I should have a little bit of a, there we go. It doesn't really matter, I filled it, but okay. So I just put in 3.2, just to guess. D, the derivative, so the slope of the function is 0 when? Well, it's 0 anywhere you could balance a marble. Okay, if you can, no wind, you get it just right, you could balance, yeah, that's slope 0, okay? So I went with this spot, and I said it was x equals 2.5. Part E, so we're supposed to do a derivative match here. So I want a thinner pencil this time, all right? So we want to match the slope when x is 0.75. So right here is 0.5, so right here is 0.75. So we want to match this slope, okay? So the whole idea is you just sort of go around the graph and try to match that. And I was saying it looks like it sort of happens right here. Okay, that's where those two slopes are, about the same, and I mean maybe a little bit further, whatever. It's not great. I went a little bit past 3. I did 3.1. So anyway, it liked all of those. Your graph may vary. All right, here's a popular one from the Calculus Center. So let's get rid of this. And how do we do it? Here we go. Boom, great. Let's put this in there. Copy image. Paste. Sweet. All right. So we have a function. Its name is g. And we have a line, which I'll just call L. Okay, and what's special is that they're tangent at the spot B, and the problem says B is equal to 7.6 comma 5.6. All right, so what it means for L to be tangent to G means the more you zoom in, the more they look the same, okay? So let me show you an example of this really quickly, and if you're in my class, then this is how I started a lecture one day. So let's just do f of x equals, we'll just do x squared, okay? Let's hit the home button, there we go. And if I focus on, say, 1 f of 1, there's that dot, and I just kind of zoom in, eventually it looks like a line, right? And we could even figure out the slope of that line. It turns out it would be slope 2. So if I did y equals slope 2, x value of 1, y value of 1, notice I just covered up in green. There it is, there it is. I suppose for those of us who might not see green-red difference, I can make it black, right? So anyway, but if I go back home, boop, there are two different curves, right? One is a line, one is the actual function. But the more I zoom in, the more they look the same. That's the idea of tangent, okay? So, let's get this back up here. Boom. So, the more they zoom in, the more they look the same. Aha! The slope of L is the same as the slope on G at B. So in other words, if I'm standing right here, then the ground under my feet, well, which is it? Is it the black ground or the blue ground? And, well, it doesn't matter. It's the same ground. The more I zoom in, the more it's the same ground. Okay, the slope of the black line is the same as the slope of the blue curve right there. Okay, so how do we say this idea in math? We would say G prime at the x value where this happens, so for me that's 7.6, is equal to L prime at this x value where that happens. Okay, but L is a line. This is just mx plus b. And so L prime, the derivative of L, derivative is slope. Derivative is slope. The slope of L is just m. So if you figure out the slope of this black line, that'll tell you G prime at your corresponding x value. So anyway, you can see the answers I input. You could pause and figure out what all goes where. But yeah, there it is. Next problem. Why are you frozen? There we go. All right. Sweet. Yeah, so this one, just sort of think it through. We have a graph. Boom. And the majority of the questions, they're not calculus. They're just reading a graph. So who is bigger, f at 8 or f at 10? And, well, f at 10. Okay, this is an increasing graph. Same kind of question happens again and again. And so the only real calculus thing happens right here. And so this is saying the slope at 4 versus the slope at 10. And so if I change my color, the slope at 4, slope at 10, the slope at 10 is bigger. Okay, so that's all that question really is. Not so bad. All right, here's the other really popular question in office hours. So compute algebraically, which they should really say from the definition. But first off, let's not do that for just a moment. Okay, so first, what is G prime of x? So we have this thing called the power rule, but we'll get there in a second. So I have to take the derivative of the G thing. I wrote x. I should have written t. Let's get out of here. All right. G prime of t. This is the derivative with respect to t of 6t squared plus 5t. Sweet. All right. So what's that? So derivatives distributes, and constants we can pull out. So it looks like this. It's 6 times the derivative of t squared plus 5 times the derivative of t, which is also t to the 1. Okay. Okay, so now we do the power rule. The power rule says that if you take the derivative of something of this form, it's n times t to the n minus 1. This is on your midterm 2 formula sheets, section 2.5. Anyway, so this is called the power rule. Power rule. This is sometimes called the sum rule, the fact that you can distribute the derivative over sums. But whatever. Okay, so hey, right here we have something that looks like this, where n is 2. And so we have 6 times 2 t to the 1, right? It'd be 2 t to the 1 because n was 2. All right, plus 5 times 1 t to the 0. T to the 0, that's just 1. So in fact, we have 12t plus 5. So that's what we should get. Sorry, that's g prime of t. So what's g prime at 9? Well, we should plug 9 in there, right? So g prime at 9 is 12 times 9 plus 5. Cool. So I'm going to go ahead and enter that really quickly. This is not how the problem wanted you to solve it, but it is the solution. There it is. All right, so what do they want you to do? So there's this word algebraically in the problem statement. We should look at g of 9 plus h minus g of 9 divided by h, and we take the limit as h goes to 0. That's what they wanted us to do. Okay, so let's do that really quick. So this is 6 times 9 plus h, 9 plus h squared plus 5 times 9 plus h. Okay, that is this. Then we have minus and g at 9. What is that? That's 6 times 9 squared plus 5 times 9. And that whole thing is g of 9. So let's color that really quick. There's g of 9. And then we're supposed to divide by h. Take the limit as h goes to 0. Okay, so that'll be some kind of really gross expression, and I just don't want to do it. So whatever, we already solved the problem. But that's how they wanted you to do it. All right. Let's see, about halfway through. Okay, so how do they want you to solve this? They want you to zoom in on the function f of x equals 5 to the x. Zoom in when x is 2. So, it's some curve. You're going to zoom in right here until you can approximate it with a line and then figure out the slope of that line, okay? I don't want to do that, so hey, here you go. If you take the derivative, the derivative of a function that looks like some number to the x power, right? What we did before, oh, hey, it's right here, the power rule, that was a variable as your base and a number as your power. Here we have a number as your base and a variable as your power. For example, 5 to the x, right? Okay, so if you want to take the derivative of something that looks like that, it turns out that it is the natural log of the base times the original function, okay? So the derivative of f, also known as f prime, is the natural log of 5, that's the base, times 5 to the x. So now if I plug in an x value, like say 2, then this number here, when you plug in that same x value, is the slope at 2 on this curve here, okay? So, all right, I plugged in 2. That's natural log of 5 times 5 squared. So there it is. All right. Okay, this one. Another really popular question in office hours. So ultimately what we're going to put here is g of, and this is x, so that's x plus h minus g of x. And we're going to divide this by, oh, no, we're not going to divide by h. It's divided by h outside. Okay, this is ultimately what we want to put there, but what is g of x? Well, g of x is 2x squared minus 2. Is that, yes. Move. I'll just make it full screen. Yeah, just minus 2. Okay, minus 2. So there's g of x. Well, what's g of x plus h? Look, g doesn't care what you feed it. What g does is it takes that number, it squares it, it multiplies by 2, and it subtracts 2. So there is g of x plus h. Now if I hit submit, first part's correct. Okay, so if you go ahead and work all of that out, and then you take a limit as h goes to 0, what you're going to get here is 4x. Your numbers may vary. I'm doing the power rule here, right? So if we look right here, the power rule, let me just scribble. I have 2 times x squared minus 2, and I'm going to take the derivative of that. So I distribute it over the sums. I have 2 times the derivative. I hit the function part. And then here, I'll write this in a sneaky way. So I'll put an x to the 0 here, right? Because x to the 0 is 1. So I just, okay, fine, whatever. And so now what happens? All right, so this is equal to 2 times, and now we have 2x to the 1. There's the power rule in action. Minus 2 times 0x to the who cares? Okay, it would be negative 1, but who cares? Because there's a 0. This whole thing is gone, okay? And so there's something else on your formula sheet. It's called the constant rule or something. It says that the derivative of some constant is 0. And so in this case, the derivative of negative 2 is 0. It's gone. It's dead. Okay, so what did we get? This is 4x. And that's what I said it was here. This is not how they want you to do it, but it's late, and so we'll just literally solve these problems. Okay, cool. Now we need to sketch a derivative. So let's look at this thing and copy and paste. All right, sketch a derivative. Here's what we should do. So find where the derivative is 0. These are spots you can balance a marble, okay? They're really spots with horizontal tangent lines, okay? And that'll sort of break up your graph. And now in between, so on these regions here, okay, let's just think about how the function behaves. And here the function's sort of going down, so this is a negative derivative. Here the function's going up, we have a positive derivative, which I'll just like f prime. And here it's going down, we have a negative derivative. So I'm looking for something in these graphs that are options that is negative sort of in this region, and then positive in this region, and then negative again. And it should hit 0 a little bit to the left of 1 and somewhere around 3, okay? So that's what I'm looking for. So I need to hit 0 a little bit to the left of 1 and somewhere around 3. So no, 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 no. Maybe, and no, and then maybe again for 8. Okay, so we're down to just 3 and 8. So which of those two options is negative, positive, negative? It's 8. Notice the y values on 8 are negative to the left of 1. They're positive between 1 and 3, and then they're negative to the right of 3. Right? Okay, so that's option 8. Sweets. Next problem. All right, this one's a little bit trickier, a little bit more cumbersome. Here we go. Oh, I was thinking the next one. Sorry. Almost done. So the function f is shown. Is that correct? Yes. All right, and so we just have to do these drop downs. All right, fine. So the point A, f is negative there. A lies below the x-axis. How about B? It looks like it's 0, and then all these are negative for me. I don't know how they randomize this problem, so they might move those points around. Right? Okay, how about the derivative? Well, at A, that derivative is 0. I could balance a marble there. Okay. At B, I would have to be pushing that uphill. I'd have to be applying some positive effort. Okay. I imagine walking along the curve. So as I walk from A to B, if you are exerting effort, like you're going uphill, that's a positive derivative. But if you're just passively rolling down the hill, negative derivative. Okay, because derivative is slope. C, I could roll down the hill there. That's a negative derivative. D, I would just bottom out. And E, I'd have to walk up that hill. Okay, now second derivative. So the second derivative, if you look like a letter U, you're positive. If you look like a lowercase n, you're negative. So at points A and B, this is positive. I'll say more about this when I can sketch in just a moment. And CD, it's all still positive. All the curves here look like portions of the letter U. Okay, so let me sketch a little bit more. And first we'll just hit submit. I'll just show you. Okay, yeah, green, it's great. All right. Derivative tells you slope. This needs to just be ingrained in your brain. So if I draw a function that looks like, say this, then notice what's happening to the slope. The slope, well, it's some negative number. Okay, oh, it's still a negative, but a little smaller. Oh, it's still negative, but a little smaller. Oh, it's 0. Oh, it's some positive, bigger positive, bigger positive, 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 bigger positive. The slope is increasing. And the word increasing, that's already talking about positive change. What's going on here is in red, I sketched a possible shape for f. And in blue, this is a possible shape for f prime. And so now the derivative of the derivative, f double prime, it's the slope of the blue thing, and the slope of the blue thing is positive. This is often called concave up. It's any portion of the letter U, so it's concave up here, it's concave up here, it's concave up here, it's concave up here. Any segment of this is considered concave up. And so on the previous problem, my dots were along something concave up. Concave down is when the function is frowning, okay? And that didn't happen to me on my last problem, at least not where any of the points were, right? Look at A and B, they're on a concave up portion. Look at C, D, E, they're on a concave up portion, right? If your dots were somewhere at a top part, then your numbers or your options, you get it. All right, here's the hard one. Here's the hard one. Let's go ahead and delete this. No, what do I want to do with this? Great. Boom. All right, it's not actually hard. It's just gross to write or draw. All right, so here's the deal. Here's what makes this kind of tricky. The graph that they give us is not of f. It's of f prime. See, it says that right at the beginning of the problem. It's the very first sentence. This is a graph of f prime, okay? So in other words, y values here correspond to the slope on the graph of f of x, which is not shown, right? So let's go ahead and let's start to show it. Let's get a guess for what it looks like, okay? So when x is right here, all right, f, the thing that's not shown that we're going to draw, needs to have a slope that's like, I don't know, 10. It needs to be stupid steep, okay? So I'm just going to do like a vertical line, whatever. By the time we get here, at this x value, now, I don't know, maybe that's like slope 5. Okay, I'm making up numbers here. But so by the time we get here, we got to have slope 5, so maybe that's something like this. When we get to this x value, we're even steeper. We're up to like 6 or something. And then this x value, we're even steeper. And then, oh, this x value, it's much, maybe that's a 3 or something. So by the time I get to this x value, I could be more mellowed out like this. And then this x value is even more mellow. Maybe that's like this. And this x value is a little bit higher again. Okay, so what might f look like? F might look like this. That might be what f looks like, okay? So you don't have to do it this way, but I'm taking the y values for each of the x spots, and I'm turning those into slopes on my function. That's why I did all these little tick marks. I should have really matched up a little better, but whatever, okay? Okay, so where is f of x the greatest at the very end? Okay, now you could figure this out without ever drawing a terrible f like I did, by just realizing that the blue curve, f prime, that's always positive. The slope is always positive. That means the original function always went uphill, okay? So when are you at the highest spot? Well, when you're done walking, and that's x6. So that's what we would put here. x6. I wonder, yeah, just type it like that, okay? Where is f of x the smallest? That's x1. It's at the beginning of your journey. And I only get to select from these x values, right? Because it's smaller over here, but whatever. Okay, where is f prime greatest? So f prime is what's shown. So where's f prime greatest of my options? That's x3. Again, it's actually like greatest up here, right? But I don't get those choices. Oops, f prime greatest, that's x3. All right, where's f prime the least? That's x5 in my case. That's the furthest down, right? Because f prime is what's shown, right? F prime is what's shown. How about f double prime? So now we're talking about the slope of what is shown. So where is the slope the greatest? Where's the steepest uphill of our options? That looks like x6 to me. And where is the steepest downhill of our options? That looks like x4. All right, there you go. So, right, this one's weird because they showed us f prime. So whenever questions ask about f prime, they're literally talking about that curve. When they ask about f double prime, they're talking about the slope of that curve. And when they ask about f, they're talking about something that's a little bit weird. It's going to be the integral, but you know we're going to get there when we get there. All right. Cool. So here's a power rule. Literally just the exponent comes down, you subtract 1 from power. Here's a power rule. The exponent comes down, you subtract 1 from power. There is one little trick, though, which is 1 over x cubed is equal to x to the minus 3. So we do that first, and that minus 3 comes down. Minus 3 minus 1 is where the minus 4 comes from. Next problem. Again, here's just power rule, and it just requires knowing that the nth root of x is x to the 1 over n. Okay? All right, so, and then this one would distribute. We'll do that really quickly. So it's going to be 3 times, and then this is the derivative of t squared minus 2. I could write times 1 because that is the derivative of t, and then plus 0 because 0 is the derivative of 1 or 11 or 1102. Okay, any number, the derivative is 0. Because if you graph y equals 11, it's a flat horizontal line, so the slope is 0, derivative is slope. There's no slope there. Okay, so anyway, there's the answer for that one. One more problem, exact same idea. We just have to write everything as a power of t. So we have 12 minus 4 t to the 1/2. This is not the answer. I'm just rewriting the problem. T to the minus 1. Okay, so now what's the derivative? Well, it's 12 times 11 t to the 10. There's the power rule. Minus 4 times 1/2 t to the minus 1/2. There's the power rule. Plus 5 times -1 t to the -2. There's the power rule. Okay, so anyway, I'd enter that and that'd be the answer. We're done. Long video. All right, see you next time.